In this video, we will be talking about transformations of functions. Transformations of functions determine the order of transformations, better known as stretches or compressions, reflections about the x-axis or y-axis, and translations or shifting of any graphs or functions. So here we have the function of fx equals to a parentheses times ax minus h close parentheses to the power of 2 plus k. So in this case, the a outside the parentheses means it's better known as a vertical, stretch, or compress. Any number that's the variable of a, it's going to be vertical, stretch, or compress. If it is that a inside the parentheses times the x value, it's gonna be horizontally stretched or compressed. But if any number based on h is subtracted or add, it's gonna be better known as horizontal shift. It's gonna be the opposite. What I mean by the opposite? The opposite means if it's inside the parentheses and you're subtracting for h, it means it's gonna be horizontal shift to the right. But if you're adding plus h, it's gonna be horizontal shift to the left. Now for k, it's better known as a vertical shift. If you're adding plus k, it will be vertical shift up. That one doesn't change. If you're subtracting minus k, it's gonna be vertical shift down. Also know that reflections will always be the negatives. For example, if you're multiplying x by x, it's gonna reflect over the y-axis. But if you're multiplying by y, it's gonna reflect over the x-axis. Let's see some examples. For question 1, we have the given graph of fx equals x squared, which is a parabola. We will sketch and determine the following questions below. For part A, we have f of x equals to x squared plus 3, which it was shifted 3 units up from the original graph, as you can see here. For part B, we have f of x equals negative x squared, which it was reflected about the x-axis from the original graph. Remember, it's a negative, which means it's reflected. For part C, we have f of x equals parentheses x minus 3 close parentheses to the power of 2, which it was shifted 3 units to the right from the original graph, as you can see here as well. For question 2, we have the given graph of f of x, x cubed, which is any polynomial to the power of 3. We will sketch and determine the following questions below. For part 8, we have f of x equals x cubed minus 2, which means it was shifted 2 units down from the original graph, as you can see here. For part B, we have f of x 2 times x cubed, which means it was stretched vertically by a factor of 2 from the original graph. And for part C, we have f of x equals negative f of x, which was reflected about the y-axis from the original graph, as you can see here. For part D, we have f of x equals 1/2 times x cubed, which means it was compressed vertically by a factor of 1/2, as you can see here in the graph. For question 3, we have the given graph of fx equals square root of x. We will sketch and determine the following questions below. For part A, we have f of x equals square root of x outside minus 2, which means it was shifted 2 units down from the original graph. For part B, we have f of x square root of x inside plus 4, which means it was shifted 4 units left from the original graph. And for part C, we have f of x 3 times square root of x, which means it was stretched vertically by a factor of 3 from the original graph, as you can see here on the graphs. For part D, we have f of x equals 1/3 times square root of x, which means it was compressed vertically by a factor of 1/3 from the original graph, as you can see here below. Finally, for question 4, we have the given graph of f of x, the absolute value of x. We will sketch and determine the following questions below. Now, for part A, we have f of x, absolute value of x, outside minus 2, which means it was shifted 2 units down from the original graph. Now, for part B, we have f of x equals absolute value x plus 2 inside the absolute value closing, which it was shifted 2 units to the left from the original graph. Now finally, for part C, we have f of x equals 3 times the absolute value of x, which was stretched vertically by a factor of 3 from the original graph, as you can see here. Thank you for watching. Bye bye.